Record. All right. When we talk about slope and rate of change, everybody's favorite.
Nope.
You're okay, I'm pretty sure.
I hope so.
I think you're okay. Just sip that Sprite. You'll be all right.
I don't think Sprite can come.
Slope and rate of change. All right. Most of you are familiar with what this is. If you are not, that is A-okay because I'm going to tell you. All right. We're still talking about graphs. We're still talking about coordinates. We're still talking about X and Y. We're still talking about lines. Okay. This is another aspect of it. So rate of change and slope are really synonyms. They're the same thing. It's just in the context of the problem when we talk about rate of change versus slope is the technical word, okay? The reason we call it rate of change sometimes, though, is I want you to think about this. We have an X and we have a Y for every coordinate, right? Let me just show you, let me start by showing you this T-chart. Let's say -1, 0, 1, 2. Looking at just the Y's, okay? Because I went up by 1 every time on the X's, but looking at just the Y's, what do you notice?
They're about twos.
So you're going up by 2's, right? Every single time here, I'm just going up by 2, right? That difference is the same every time I change. I go up 1 here and I go up 2 here, right? That doesn't change. And that's what's special about lines is they have that constant rate of change, that same rate of change for every single value. Okay, so what rate of change is? Rate of change is the change in Y, okay? So pick 2 points, the change in Y divided by the change in X. So if I gave you this table of values and I said, hey, what do you think the rate of change is here? What would you tell me? 2. Why? 2 divided by 1 is 2. You're absolutely right. Y is going up by 2, X is going up by 1, so it has an average rate of change of 2. Does that make sense? All right, so in general, rate of change is going to be in the form of a word problem. Slope is going to be in the form of just find the slope between these 2 points. All right, go ahead, Patrick. Let's say this is number of games you bought for your, I don't know, what do y'all play now? Xbox. No, what game? PlayStation, Xbox?
PlayStation is better than Xbox.
Okay, we play Nintendo Switch at my house.
Switch players are bad.
All right. Well, we have an Xbox too, but we don't let my son get on the internet with it because. All right, so let's say we're gonna look at the cost, the number of games versus the cost. So let's pretend like they all cost the same amount. Okay, we know that they vary a little bit, but on average, what would you say? $60? Is that a fair? 60 for a game?
60 to 100.
For like Xbox or PlayStation.
60 to 160.
Okay. To 160?
Yeah. The deluxe edition at 2K20 that costs 160.
All right. So let's say about $60 a piece. So one would be 60. How many would 2 be? How about 3? About 4? 240. What is the average rate of change for the cost of a game. How are you doing that? What are you doing? The rate of change would be the change in y, and just pick any two. It doesn't matter which two you pick. Y is going up by 60, and x is going up by 1. So the rate of change is 60. Does that make sense? So when we say it, though, we have to say it a little bit differently.
That's all you have to do.
It's $60 per game. So $60 for one game. So $60 per game. What if I gave it to you as a graph?
I mean, once it goes up, it's point.
Y'all got this?
This is our homework.
Oh, so.
It gives you the graph, and we show.
Let me show you.
No, I'm saying it gives you the chart, and we just.
And you find the rate of change. And the units. So you'd have to say the rate of change is not just 60, it's $60 per game.
That's so easy.
But yeah, it is.
We got it.
This will be cells in millions. This is the total, boys, stop drawing on that board back there. Total pet spending. How much people in the U.S. spend on their pets per year? Per year. Per year. Let's see. We're gonna go by twos here. How much y'all think you spend on your pets?
0, 'cause I ain't got one.
Probably a year. Oh, yeah, probably. It depends on what year it is. 'Cause I got like hunting dogs.
I was gonna say, think about everything. Like, think about vet bills. Think about food,
Well-
shots, and like I have chickens.
My dog just had surgery. So.
You think that's funny? Why is that funny?
I don't know. You just know who's like the type of person that have chicken. You know,
So, what does a person who has chickens look like?
I mean, they probably like skinny, like you know, like the no.
Let me pause this video again since George hurt my feelings so bad. 15, 20, 25, 30. So only skinny people can have chickens.
No, I don't want to saying that.
55. Dude, you are too fat for a chicken. All right, let me put the points on here. 2, 4.
You just lost all your brownie points.
You know what, that's you should have.
George.
And George?
It's okay, George.
I hope so.
I can't hardly see this little.
You should have just said she doesn't look like a farm.
Do we have any more parents with conflicts of interest? Just for future references.
You have to schedule parents' conference, don't you?
Yeah.
They just don't happen? Good.
All right, so I didn't plan out my little graph really well, but I put the numbers there so you can see the y values at those points. And this is actually at 11, this is at 7, and this is at 3. What is the rate of change for the amount of money people spend on pets?
9.
Mm.
9. No.
Tell me what you're doing. You're saying it, but you're not telling me what you're doing. How could I find it a little bit easier than that? Divide what? How is y changing? Remember, rate of change is change in y over change in x. So pick 2 points. Let's do this one and this one. How has y changed to get from here to here? Subtract them from each other. You're exactly right. So what is 41.2 minus 32.4?
9.2.
Okay. How does x change over those values? It goes from 3 to 7. So it goes by 4, right? So what is 9.2 divided by 4?
2 point something. Yeah, I mean, right?
I did.
2 point something.
2.3. Give me the units. 2.3. What was on top? In millions. So $2.3 million. What was on the bottom?
Years.
Years per year. So on average, the U.S. spends $2.3 million per year on their pets. Does that make sense what we did? I know. I think so too.
What about kids? What do you think? You spend on kids?
Oh my gosh, I'd hate to see that. A lot. Y'all are expensive, I'll just tell you that. All right, let's look at slope. Slope. All right, slope is the same thing as rate of change. Okay, same thing, but we're looking at x and y values instead of quite so as a word problem. Okay, so to find slope, if I have 2 points, we'll say x1, y1, x2, y2. It's the same thing. Slope, which we're going to let be m, okay, is the difference in the y's, and it does not matter which one you start with. Most books start with y2 for some reason. Over the difference in the x's. I could also write it this way. How else have you heard slope described before? Yes. Rise. Overrun. Because the y-axis rises and the x-axis runs. Rise, overrun. Okay? But it's still change in y divided by change in x every single time. Okay? All right, so let's look. Slope also, understand, describes the what of the line. How it starts with an S.
Slope.
An ST.
Slope.
Static.
What do you call steepness? That's what I wanted you to say. I sure did you? I'm sorry. It also describes the steepness of the line. Okay? So how steep? So the bigger the slope gets, the steeper that line gets. So it's like walking up a hill and the hill's getting really hard to walk up, right? The steeper it is, the harder it is to walk up. All right. Let's look at one. Actually, before we do one, you do remember it?
Yeah, and I remember. I made a
We're going to change that this time. We're going to do better. 4 different kinds with slope, okay? We have positive slope. Positive slope looks like you're walking up a hill. Okay? It rises as it runs. Negative slope, it goes downhill. You're walking down a hill. Then you've got 2 special scenarios. What are they? 0 and undefined. You're exactly right. So a 0 slope is a horizontal line. And an undefined slope. What other kind? There's only one other kind of line. It ain't squiggly. Up and down. You're exactly right. George said a squiggly line.
Patrick, well, it is on
Well, it's also not a line. A squiggly line is not a line. All right, so let's find some slopes. Find the slope of the line that goes through the points -2, 0, and 1, 5. Find the slope.
I'm allergic to that.
Okay. We're going to just find the slope. So listen, take the points. Let this be maybe x1, y1, x2, y2. Remember, it's still rate of change, y'all. It's the same thing. Difference of the y's divided by difference of the x's. And let me give you a hint, because a lot of people teach this. It's always y2 minus y1. It doesn't matter which one you start with on the top, but whatever point you start with on the top, make sure you start with that one on the bottom also. Okay, so difference of the y's over difference of the x's. The y has to stay on top because it's rise over run, and the y is the one that rises. So that's y. All right, so 0 minus 5 is what? -5 over. What's -2 minus 1? -3. What's a negative divided by a negative? Did anyone in here do 5 minus 0 instead of 0 minus 5?
That's what I was about to say.
Okay. Watch what happens if I had done that. Let's say I started with this point and I did 5 minus 0, because you have to do the y's and then you have to do the x's. 1 minus -2. What is 5 minus 0? 5. What's 1 minus -2? +3. Look, they're the same. Okay. Now understand what this means. This is a positive slope, so what does my line look like? Looks like I'm walking up a hill, right? Straight uphill. Positive slope. Does that make sense to everybody?
Yes.
Let's do another one.
Is this all on one? Is that it?
Slope and rate of change. I don't think you have any graphing tonight. I'll check some. Let's look at this one. Let me give it to you a different way. Find the slope that passes through these 2 points. Same thing. The most important thing to remember here is y on top and x on the bottom. Okay, you have to do it that way. -4 minus -3 over. Now listen, this is really important because I started with 4 up top. I have to start with 3 on the bottom. If I'd started with -3 up top, I'd have to start with 2 on the bottom. Okay? You got to start with the same point, top and bottom. But as far as which one you do, it doesn't matter. All right, so I got subtracted the y's. Now I'm going to subtract the x's. What is 4 minus -3? 7. That's exactly right, CJ. What's -3 minus 2? -5. This time I have a negative slope, so what is my line going to look like?
You going down.
Downhill. That's right, downhill. There you go. Let me ask you this. If you had a whole line and you picked 2 points off of it, would it matter what 2 points you picked to find the slope? No. You can pick any 2 points on the line. Okay? Y'all might pick 1 point, y'all might pick another one, but you should get the same slope because lines have a constant rate of change, which means the rate of change is the same between any points on the line. Okay? That's what makes a line a line. All right, Riley, put that away, please. All right, let's do one more. You do this one. Find the slope between the 2 points. You sure about that? Y'all sure about that?
No. I did not get that.
Somebody over here said it. What is -1 minus -1? Same, change.
Oh, my fault.
Yeah, right.
No, it's zero. Going down here.
No, it ain't going down. It's -5. It's a zero slope.
Look, watch this. If this will come up. -1 minus -1. Just in case you didn't believe me. Because you do same, change. So it's really -1 plus 1, which is 0. Okay. On the bottom, -3 minus 2, -5. So it's, what kind of line is that?
Zero.
I see this and I see this. Which one is it? Look at your notes. It's this one. It's this one. Horizontal line. Horizontal line. There's no change in y. That's right. Y stays the same and it's constant, which means it's horizontal. One more. Bet you can't guess what this one's going to be.
Negative.
Find the slope.
Oh, I got it. Negative.
Is it? Sure. How sure are you? Pretty sure? Really sure? Chicken skinny sure?
No. Okay, no. It's almost 7 over next 4.
CJ! Come on now. I know better. Try again.
Is it wrong?
It's just like the last one. Look at the bottom. What happens?
You always feeling something. You just can't.
Guys, focus. Listen. CJ, tell them why. Tell them what happened. Tell them what happened. What's the slope? You just said, oh, I see.
Told you it was negative.
What's the top? What's on the bottom?
Zero.
See, I didn't put the second.
All right, undefined. Undefined because I can't ever divide by 0. That's a no-no in math. What kind of line is that? There you go. It's up and down this time. Let's see how good you really are with slope. Here's your challenge. Okay, and I'm going to record. If I have these 2 points, oh dear.
You know what?
Man,
It was easy as you
right
did.
now. Oh, I know. I think I know.
If the slope is 5, how could I find out what in the world that r could be?
You put 5 in? Put the 5 in.
I don't want, well, the slope is 5.
Wait,
Or -5. The slope is, all right, so let's think about this. We know how to find slope, right? To find slope, we do what? Changing y's. So 6 minus -4 over what? -2 minus r. Right? But this time it's going to equal -5. This time I'm telling you what it equals, and I'm going to get you to find out what that value is there. So let's clean it up a little bit. What is 6 minus -4? 10.
One.
I figured it out.
He's solved the whole problem. Now, here's what I'm going to do. I'm going to put this over 1. Okay? Because I now have a what? What is this called? Two fractions that equal each other. What's it called? Starts with a P?
Proportion.
A proportion. Good job, Xavier. And to solve
That's like English.
to solve a proportion, what do I do? Y'all are pros at this. Cross multiply.
Yes, sir.
So -5 times -2 minus r
How's the percent?
equals 10 times 1.
Told you.
Now this is something you can solve, right? This is the hardest part about slope in this section. But you got a few that pop up on your homework, so I want to make sure I went over one.
You're still good.
What's -5 times -2?
Negative. I had 10.
What's -5 times -r? Positive 5r. Get r by itself. Subtract 10. Uh-oh. Oh, no, I don't know what to do.
Can't divide by 0.
I've got 0 on one side. And I say that because this is what y'all always do. You get to this and you go, I don't know. Can you divide 0 by something? Sure you can. It's a number just like anything. The only thing you can't do with 0 is divide by 0. 0 can't be in the bottom, but 0 can be in the top anytime you want it to. So in other words, I could divide by 5. And think about it. Think about the way an equation works. 5 times what gives you 0? 0. I didn't mean that line to be there. All right.